This video details the three most important rules for integrating an equation symbolically, namely the power rule, the constant multiple rule, and the sum rule. All right, let's start with the power rule. So you'll notice, if you're already familiar with the differentiation rules that we covered earlier in this Calculus 2 subject of my Machine Learning Foundation series, that the rules we're covering in this video, they have a corresponding rule in the derivative rules, and they kind of perform the inverse. So we had a power rule for derivatives that kind of did the opposite of what we're going to see in this power rule for integration. So if we're integrating this function here, which is x to the power of n, then according to the power rule, this becomes x n plus 1 divided by n plus 1. So the power rule for differentiation went the other way. If we had x to the n and we differentiated, that equation became x to the power of n minus 1, and we had n in front. Here, with the power rule of integration, we have x to the power of n plus 1, and it's all over n plus 1. So note here that because of this n plus 1 happening in the denominator and how you can't divide by 0, this means that you can't integrate something that's to the power of -1, because you'd end up with -1 plus 1 in the denominator. And yeah, you'd be trying to divide by 0, and that's impossible. So that's a limitation there. Another key thing to note that is quite different from anything that we had to deal with differentiation is that we have to add this constant term. So the reason why we need this is because there may have been some constant here that was lost by differentiation. So remember from the derivative rules that if we differentiate a constant, it becomes 0. And so that means that if we had some equation that had a constant term, we differentiated that equation, then that constant term would have been lost. And so when we integrate going the other way, we need to consider that there might have been some constant that we've just completely lost track of. So we use capital letter C to indicate that this constant might be there. In a later video, we'll tackle definite integrals, which have a way of eliminating this constant. But when we're dealing with indefinite integrals, this constant will be there, and that is why they're indefinite. Okay, so here's an example with numbers. So if we have this expression here, x to the power of 4, and we integrate it, then it becomes x to the power of 5 plus 1, and we divide by that same number, 5. And then don't forget to add that constant c. So that's the power rule. Another really important integration rule is the constant multiple rule. Again, it has a corresponding rule in the differential branch of calculus. And it's really similar here. It's just this idea that if you have a constant in front of some function that you're integrating, you can ignore that constant while you integrate the function, and then bring the constant back in later after you have integrated it. And of course, don't forget that constant term. So to make this rule concrete, let's work through an example with real numbers. So let's say we're integrating this expression 9x squared. Well, according to the constant multiple rule, we can simply ignore the constant 9, bring that outside of the integration, and then integrate whatever's left. In this case, we can very simply integrate this according to the power rule. So this will become x cubed divided by 3. And then after we've done that integration, we can bring the 9 back into the picture. So we have 9x cubed divided by 3. And don't forget that you have that constant term. And this simplifies nicely because 9 can be divided evenly by 3. And so we're left with 3x cubed plus c as our integral of 9x squared. And finally, here is the sum rule. Again, analogous to the sum rule in differential calculus. It's the same idea that if you have separate terms that you're integrating, you can integrate those separately, just like you can differentiate terms separately. All right, so let's see it with some numbers. Let's say we have x to the power of 4 plus 9x squared. According to the sum rule, we can integrate these two terms separately. So let's integrate the first term first. X to the power of 4, as we saw a couple of slides ago, becomes x to the power of 5 divided by 5. And this second term here, 9x squared, as we saw on the preceding slide, becomes 3x cubed. And so that's it. Just don't forget that you have your constant that is still there, making this an indefinite integral. Neat. Hopefully those rules were crystal clear. The next video features a handful of fun exercises to give you a chance to practice integrating equations on your own.